This is the Agentic Engineering Summit. So can you raise your hand if you're building with AI, shipping code with AI? Okay, cool. And keep your hands raised if you deeply understand everything that you're merging. Okay, so that's what I want to talk about. I'm Zach. I'm an engineer at Elise AI. So we build AI agents for housing and healthcare. We're actually in 1 in 6 apartments in the country, so there's a decent chance that you've interacted with one of our agents without realizing it. Like most of you, most of our team has been shipping more and more with agents for the past year. And we're shipping faster than we ever have, and that's really exciting. But that velocity comes with some baggage, as I'm sure you're all familiar. So I'm sure you've seen stuff like this. This is some exaggerated AI slop from some of the worst stuff I've seen. Useless in-memory cache optimizations, fallbacks on top of fallbacks, terrible error handling, defaulting to admin. This is slop in itself. And had I stepped up here 6 months ago, I probably would have spent the whole time complaining to you about stuff like this. But I don't think this is our biggest issue anymore. As the models have gotten smarter, the slop is going away slowly, and I expect that the slop will converge to 0 pretty quickly. The problem that I don't think is going away and is not going to get better as the models get better is this growing gap between the code that we ship and our mental models of our code bases. So as the models get better, we trust them more. We give them bigger tasks, we steer them a little less, and we're able to ship code faster than we ever have been able to before. And that's super exciting, and I expect that as the models get better, this gap will increase. And I think that's a trap, because as the agents take on harder and harder tasks, at the end of the day, all that will be left for us humans is the stuff that the models still struggle with. The nastiest bugs, the things that require context that takes a long time to build up. And I think that's a huge problem. The trap there is you build the intuition, the system knowledge that you need to do the hard parts by doing these easier tasks. You build that intuition by doing the boring problems, by building the boilerplate, by putting those CRUD endpoints together, by doing the debugging. And if you hand that all off to the agent, I think pretty soon you'll wind up in this situation where you have this nasty bug and Claude can't figure it out. And you can't figure it out either because you're not deep enough in your code base. And I think the natural response to that, if you're very AGI pilled, might be, well, the models are just going to get better. So they're just going to do everything. They're going to hit that top line. And to that I say, maybe. But there's a huge difference between handling almost everything and handling everything all the time. And that difference matters because until coding agents are writing perfect code, if there is such a thing, until their human level intelligence are better, someone's going to need to be able to catch their mistakes. You're going to need to be able to take the controls, and you can't take controls of something that you don't understand. So I'm a bit of an aviation nerd, so I had to find a way to sneak an aviation analogy in here. And I actually saw that the next talk by Zane might make a similar analogy, so I'm glad I'm not the only one. But pilots have faced this kind of issue for decades. Automation has been around in aviation for a long time because autopilots generally outperform humans at tasks in flight. And what happened when they introduced automation is over a generation, they noticed this pattern emerge. The machines were flying themselves more and more, and pilots got worse at flying manually. And they actually coined a term to refer to these pilots. They called them children of the magenta line. The magenta line referring to this instrument that is generally associated with autopilots. And these are the pilots that can't fly without the assistance of autopilots. But the thing is that every so often the bill comes due So on June 1st, 2009, Air France 447 was just off the coast of the Atlantic, and their pitot tube iced over, which caused their airspeed indicator to behave erratically. And the autopilot did exactly what it was designed to do. It clicked off, and it handed the airplane back to the pilots. And the plane was perfectly flyable. It was just an instrumentation error. Plane was totally airworthy. And the pilots couldn't save it. They pulled up when they should have pushed down. They stalled the aircraft into the water. And it was just 4 minutes from the moment the autopilot clicked off to, horrible disaster. And I guess, why do I bring this up? Obviously, it's an imperfect metaphor. Not all the code that we write is a matter of life or death. But a lot of the code we ship is incredibly load-bearing in people's days and the problems they solve for their business. Or for companies like Elise AI, we're building products that power housing and healthcare, which are two critical services. So when we have issues, those bugs are not abstract in any way. It's a resident who's locked out of their apartment at 2 a.m. and can't get in and can't get connected to anybody to help them. Or it's a patient who can't get in touch with the doctor that they really want to talk to. And I think if you're building any product that's valuable, then you better hope that there's people that rely on it. And if someone relies on your product, then it needs to be available. So hopefully at this point, I've convinced you all that it's important to understand the code that you ship. So what do we do? Because now we're able to ship faster than ever, and velocity is important. Well, what did the FAA do? They did not turn off the autopilot. They didn't pull back the automation. They did some regulation, and they basically asked the airlines to have pilots fly by hand more, to put in the reps on the days they strictly didn't need to, so that their flying skills would be there on the days that they did. So how can we apply that to software engineering? The truth is that it's much easier to talk about this problem than it is to give you a good solution, and I don't have a magic bullet. But here are some of the things that we're trying out at Elise that we do on my team that I think helps. So the first thing I would instruct you to do is, when you get back to your laptop, or I see some of you have them open, look at your commits over the past week and go through some of the commits and see if you can clearly articulate the problem that you were solving. What was the bug in detail? What broke down? What was the feature? What was the improvement? And then see if you can clearly articulate what change you made to the system. How did your code change the architecture of the system? And you can sort of benchmark your understanding versus the code actually running in production. And that's sort of the first step to fixing this, seeing how far that drift is. Then I think it's a bit open-ended. One thing that I do that I think doesn't get talked about enough is the agents are not only incredible at giving you velocity to ship features, but they give you a lot of velocity in understanding your code. So I think, before this agentic era, understanding your code took a long time. I think everybody who joined a company just knows it took a while to ramp up. A lot of reading manual lines, a lot of stepping up and down the stack. Maybe sometimes you had to look at the PR history and see what code was here before, maybe reading through Slack threads or tickets. And the agents give you a lot of that leverage now, and you don't have to read every line. You can take advantage of the agent's ability to quickly summarize things. And if you're like me, I'm a visual learner. I love diagrams. And these coding agents are amazing at producing diagrams, ASCII, HTML, that helps you quickly absorb what's in your code base. So I think that's how you can sort of keep your understanding of the code base up with this increased velocity of shipping code. And then the last thing that I think is really important and hard is you have to build an engineering culture where people want to understand what they ship, because they recognize that the best products get built and the people who are shipping them understand how it works. So that in that 1% case, just like the airliner, where things go wrong, people can join in and they can fix it. So if there's one thing you take away from this talk, Don't turn off the automation. Keep the autopilot. The agents are amazing. They're going to give you so much velocity, but don't ship things that you don't understand. If you ship things that you don't understand, your agent is not just writing your code. It's turning you into the thing that you swore you would never become, a middle manager. Thank you.